All right, hi guys, this is video number 11. I'm sorry, this is video number 13. And this is chapter 8, section 2. And this is all about the law of cosines. So the last video was about the law of sines, which was about solving oblique triangles. But that only worked if you had, let's say you had a triangle. That worked if you had an angle and its opposite side and any other angle or side. Well, in the law of cosines, what you can either have is, okay, so this is used, kind of give you some information here, used to solve oblique triangles also. And it's used for two specific cases. So this is used when you have all three sides and no angles. Or it can be used when you have two sides and an included angle. And what that means in a picture, if I have a triangle and I have two sides and the angle that's in between them, that means an included angle. Okay, so that's an example of that. Or if I have two sides and an included angle, or two sides and an included angle, right? That's how that would kind of be. So here is the law of cosines. There are three different formulas for it. The first formula is a squared equals b squared plus c squared minus 2bc times the cosine of a. The second one looks like b squared equals a squared plus c squared minus 2ac times the cosine of b. And the last one looks like c squared equals a squared plus b squared minus 2ab times the cosine of c. So notice whatever side is on the far left-hand side, that's the angle that you're finding on the far right-hand side. So side A, side B, angle B. And then the two other sides are the ones used. So if A is on the left, then you use B and C in the formula. Okay, if B is on the left, you use A and C in the formula. And if C is on the left, you use A and B in the formula. So it doesn't really matter which one of these you technically use, as long as you're using two sides and the included angle, and that's how it's going to work out for you every single time. So let's see how this is going to work in an example. I'm going to go to a new screen here, get myself a pen, make it a black pen. All right, so if A is 30 degrees, little b is 10, and c is 12, solve the triangle. Sorry, I just squished that in there. All right, so it's helpful if you draw yourself a picture, label that information. You can put A, B, and C anywhere you want, and then just label appropriately. So A would be 30, side B would be across from angle B, so that would be 10. Side C would be across from angle C, so that would be 12. And you can see here that we have the two sides with the included angle, like I was mentioning before. So I have angle A. So I'm going to scoot back to the formulas on the other page. Okay, I have angle A, which means I have sides B and C, and so I'm going to use this formula right here because of the information that I was given in the problem, okay? So I'm going to rewrite that formula on my other page. So I'm going to use a squared equals b squared plus c squared minus 2bc cosine of a. Now, all of these pieces here, just to note, are all multiplied together, right? So it's a negative 2 times b times c times the cosine of a. So let's just plug some stuff in here. All right, so we're going to keep the a squared. We don't know what that is. That's what we're solving for. B is 10. And I'm going to write all this out. Typically, I would plop 100 right in there because 10 squared is 100. But I'm going to write this out and show you the substitution. B is 10, C is 12, and then cosine A is 30. And you're just going to be putting this in a calculator. I know cosine 30 is something that you know from your unit circle, and that's rad 3 over 2. But we're just going to put it in and use the decimal equivalents for these, okay? So here I'm going to have a 100 plus a 144 minus, now keep in mind these numbers are all multiplied together, so we're going to have a 240 there times cosine of 30, okay? And again, I'll add these two guys, so I'm going to bring my a squareds down. This will give me 244 minus 240 times cosine of 30. Here's the mistake you should not make. Don't go 244 minus 240 and do 4 times cosine 30. This is all one piece of information, right? So in your calculator, you're going to put in 244 minus 240 cosine 30. So if I go over to my calculator here, and let's bring up, yeah, I can do that here. Desmos, go to Math Tools, get the scientific calculator. So here I'm going to go 244 and subtract, whoop, go away, get away, minus 240 times cosine of 30. And we're going to get 36.15390309. So I would take all of that information. I would, when you guys are doing this in a calculator, take all of that information. And now that's a squared. So let's pop back over here. I'm just going to write that whole thing down. I'm going to use 4 decimal places, I guess. 1539. So we have a squared equals 36.1539. Now that's a squared, right? So the next step would be to take the root and take the root. So I'm going to get a equals, and I don't know how familiar you guys are with using the answer button in these calculators, but if you, let me see, and I'm not super familiar with using these calculators, so I want to take this whole answer, 36.1539. I'm going to hit enter. I think this is the enter button. And now I'm going to say I want to take the root of the answer. So the root, and for the answer, you can just hit that, and it will use the answer from the previous question and take all of it. It's better to take too much and then round than not take enough. So now I'm going to say I want 6.013. 6.013. So this is 6.013. And that is side A. So that's this guy. Okay? Now, once we know an angle and its corresponding side, and I'm not going to finish this for you, but the idea here is you would now use law of sines to find another angle. Right, so you could use this. So you would set it up and go 6.013 over the sine of 30 equals, maybe we'll do B, right? So you could do 10 over the sine of B, use law of sines and find angle B, and then you can just subtract from 180 to find C, right? So you would find another angle and then subtract to find the last one. So that's how you would solve a triangle when you have two sides and an included angle. Let's do one where you have all three sides. It works out a little bit differently. Okay? All right, so here's our next example. If you're given A equals 20, B equals 25, and C equals 18, solve the triangle. Okay, so I'm going to take any one of these formulas, and I'm going to choose this one. A squared equals B squared plus C squared minus 2BC cosine of A. Now, what we're trying to do, we know all three of these sides. So what I'm going to do here is actually solve this equation and get the cosine of A all by itself. Okay, so I am going to isolate the cosine of A to make this equation simpler. So what we're going to do is we're going to subtract off a B squared and subtract off a C squared. So that will give me A squared minus B squared minus C squared equals negative 2BC cosine of A, right? We get rid of these, get rid of these. Well, now what I'm going to do is I'm going to divide this side by a negative 2BC to cancel this out. What I do to one side, I have to do to the other, and that gets this cosine of A all by itself. So if you have all three sides, use this formula. Cosine of A equals A squared minus B squared minus C squared over negative 2BC. What we're going to do, plug all those things in, and then we'll do inverse cosine and find out what the actual angle is. So we're going to find the angle. So you're going to use this if you want to find angle A. Okay, so here is how we are actually going to use this. All right, so we've been given this problem up above, and we have A is 20, B is 25, C is 18. So we're going to plug everything into the right side of this equation only. So we're going to keep this cosine of A. That's what we don't know anything about. A is 20, so we have 20 squared minus 25 squared minus 18 squared over negative 2 times 25 times 18. Now, I already did this math somewhere, so I've got these numbers already stored. We're going to go to red. Cosine of A is equal to 400 minus 625 minus 324 all over negative 900. And so then when you do one more step here, you get cosine of A equals negative 549 over negative 900. Now, because these are both negative, you could just take and make these both positive. But essentially what we're going to do here is go inverse cosine 549 over 900, and that will give us A. So angle A is going to be approximately equal to, let's go plop that into Desmos and see what we get. Okay, so we're going to go here. We'll hit enter, and we're going to go inverse cosine, and we're going to go 549 divided by 900, and it's 52.41 degrees. 52.41 degrees. And I don't remember if this was to the nearest 10th or the nearest 100th or whatever. Remember that tenths are the first decimal place, hundredths are the second. So you'll need to figure out where you want to go with that. But if I didn't even draw a triangle to do this, right? So if I do draw a triangle, label it however you want, A, B, C. We said side A was 20, B was 25, C was 18. We just found angle A, which was 52.4. And now I have an angle and its corresponding side. You have another side, and you could set up law of sines and go ahead and find that piece of information. All right, the other couple things that we need to talk about in this video is area of a triangle. So area of an oblique triangle. Let me get a pen. So area of a triangle. And so this is an oblique triangle, not where you're using area equals 1/2 base times height. So this is something called Heron's formula. And this is used on an oblique triangle. And here is what this formula is. Oh, also one more statement. You're going to use this when you know all three sides of a triangle. And so if you don't know all three sides, you may have to use law of sines or law of cosines in order to find some missing sides. But here is this formula. It is A for area equals the square root of S times S minus A times S minus B times S minus C, where S equals A plus B plus C over 2, and A, B, and C are side lengths. Okay, so here is an example of a question. Use Heron's formula to find the area of a triangle whose sides have the length A equals 10, B equals 15, and C equals 7. So the first thing you're going to want to do here is to find S. And that is A plus B plus C over 2, which in this case, sorry about all the distractions in the background. If you can hear them, I'm sure you can hear them. I'm going to have to go, I already had to go, will have to go cut out a distraction that somebody popped their head in my door. I usually make these at home, and I'm making this one at school because I'm running out of time. So what have we got here? This is 32 over 2, which is 16. So S equals 16. So S equals 16, and now we're going to plug into Heron's formula. So this is going to look like this. So we're going to have area equals the big old root of S. S is 16. So 16, so I'm going looking back up here, right? So S minus A, and A is 10, so this is going to be 16 minus 10 times 16 minus 15. I got to shove that phone up. And then times 16 minus 7. All right, so start by doing your subtraction. 16 times 6 times 1 times 9. And then you're going to find the root of all of that. That is the root of 864. And then quite literally just take the root of that 684. And you're going to get approximately 29.4 is the area of that triangle. And that's an example of Heron's formula. It's actually very, very easy to use. There is another example of an area formula for triangles, though, that you're going to need if you don't have all three sides of the triangle. You can shortcut your work. I could be really mean and make you go find all of that stuff, but there's an easier one. So it looks like this. Area equals 1/2 BC sine of A, or area equals 1/2 AC sine of B, or area equals 1/2 AB sine of C. And so this one can be used basically with two sides and an included angle is what's going to happen. So used with two sides and an included angle. Okay, so here's a problem, and this came straight from varsity, and it's going to be in this section that you're going to be doing. It says given A is 7, B is 12, and gamma, and remember that's like a C, is 58.5 degrees. Find the area of the triangle. Okay, so I'm going to scroll up here just a little bit. I'm going to label alpha, beta, gamma. We're going to label this guy 58.5. Alpha, A would go across from alpha, so that's 7. B would go across from beta, that's 12. And so gamma is like C, right? So I'm going to use this formula because I have A, B, and angle C. And so let's fill that in. We have area equals 1/2 times A times B times the sine of 58.5. And you can just go straight to a calculator, figure that out. So we'll just jump over to Desmos. We'll hit enter here. And we're going to go 1/2, which is just 0.5, right? We'll just shortcut that, times 7 times 12. Oh, Lord. Back that up. Times 12 times, we need the sine, which is under function, sine of 58.5. And we get 35.81. So this is area equals, approximately equals 35.81. Okay, so these formulas are really straightforward to use. And this is for 8.2. Okay, law of cosines. All righty, that's about it in this one. Toodaloo, peeps.